Well, hello there and welcome back to the Solar Professor video series. I'm your Solar Professor, Steve Geiger. And you may be asking yourself, Professor, what the heck are you wearing today? Well, we'll get to that in just a minute. But today, this is one of the most important topics I think we can cover in this video series. I've recorded a lot of videos for you guys, and really this is a rudimentary, extremely important topic that we're going to be covering today. And we'll get through it as quickly as we possibly can, but I want to be as complete as we possibly can as well. So let's go ahead and get started and see what it is. Today we're going to be talking about photovoltaic safety. And you'll notice, as I always do, we have the slide deck available here in the presentation, and that is available on my website at solarprofessor.info. It's in the instructional section, and you'll see the YouTube video series area there, and then you can simply download this file. Anyways, what we're going to be talking about is really critical. It's OSHA topics for solar safety. Not only am I a solar professor, as well as a solar contractor, I am also an OSHA outreach trainer, and I've taught the OSHA 10 and OSHA 30 classes for several years now as well. And so this is something that's very dear to me and very important in the work that I do, both in the classroom as well as out on the job site. Solar safety is just paramount for what we do in this industry. So here's some of the things that we're going to cover. You notice I've mentioned here, this is most common, these specific ones for solar installation work. When I'm doing the OSHA 10, it is a full 10 hours of construction training, but today I'm just going to try to keep it as brief as possible, but get to the important topics here, and they are falls, electrocution, wearing PPE, which is personal protective equipment, and then other topics here, ladders, excavations, and power tools. So let's continue to move on forward. First one here is falls. It's part of the OSHA, they call it the Focus 4. It used to actually be called the Fatal 4. And falls is one of the largest killers in the construction industry. And it's 34% of all deaths are caused by falls. That's a really quite high number in the industry. And so I definitely wanted to point that out. But let's go ahead and continue moving on through the presentation here. A couple of things that you can do for fall protection, and I have 5 of them highlighted right here. So the first 2 are the most used. It's the personal fall arrest system, and actually, guess what? That's part of what I'm wearing right now. We'll see that in just a moment. In fact, there's another one right here in this picture. Guardrail system is something that we'll use in solar as well. It doesn't work in all applications and on all roofs, but it is certainly something that works well for us to have freedom of movement on the roof. A couple of other things here. I'm not going to go over them because I rarely see them used. Number 3 on here is safety nets, and you can see the picture of it right here. Number 4 is a strong cover, and we'll actually use that every now and again. If there's a skylight, for example, on a roof, we can simply take a few minutes, get some wood together, and build a cover for it so that somebody doesn't trip and then actually fall through the skylight, and that could become an ugly situation. And then number 5 is something that people probably don't know too much about, and it's actually a safety monitor. OSHA allows you to have a safety monitor out there, and what I mean by that, and you notice there's a megaphone here, is somebody who is on the roof or at the line of sight of work, and simply their job is to watch and make sure that folks are working safely, folks are not getting too close to the edge of the roof. If they are, they're going to be warned not to. Really have never seen that used. Most companies don't want to spend the extra money to hire somebody just to simply stand there and watch the whole time, or sit there and watch. The other problem with that is you can't be watching every single second either, and that's hard to do. So the most common, again, are these 2 right here, the personal fall arrest system and then the guardrail system. So let's take a look at those a little bit deeper. Here is the personal fall arrest system. You'll notice that the fellow over here is actually wearing a harness very similar to what I am wearing, and this is the full body harness, and what it does is it wraps around the back. There's a D-ring on there, and of course that's going to attach to a lifeline, which attaches to an anchor. Here's a common system that you can buy. Most hardware stores are going to have something. There's really no excuse not to have a harness. They're not very expensive. You can get this bucket set up. I actually have an example of it right here. So here's a bucket, and you can see there's the lifeline in there. And then this is a temporary anchor that can be screwed to the roof. And then, of course, this is the harness itself. Here are some other devices that we use as well. These are actually permanent anchors, and these are fantastic because if you're doing a solar job, chances are down the road you may need to maintain that system. So that means you may need to go out and go back on the roof. So we can install some permanent anchors. Notice I wrote on here, the anchors, a single anchor is for one person, and it needs to hold up to 5,000 pounds. And you may ask, Professor, why the heck would it need to hold that much? You know, people don't weigh that much. Well, you know, and that's about the weight of a small car. If you were to fall off the roof, there's inertia. You may start falling and you gain speed as you're doing it, and that's why it's very important. And of course this is overkill, but it's very important to follow the instructions on the actual product. I actually have one here. This one we use for tile roofs. And this is a permanent anchor. It stays there. You see how long it is, and then we simply nail it in according to the directions on here. That's very, very important to follow the instructions. The instructions on here, what they tell you is we're going to use specific size nails, and we're going to fill every single hole on here so that it then is rated for the 5,000 pounds. Again, one person on this, there's another one here. This is for the ridge of the roof if you want to use that particular type as well. The other thing that you can do is you can get fancy with these particular products. I actually have here this is a retractable lifeline, and it's kind of like a seat belt, and so it'll just pull, and in fact this is seat belt material right here. Some of them have metal cords in them. There's different ones that you can get. We often refer to this as a yo-yo in the industry. And what it does is if you start to fall, it'll lock and it will catch you. Very similar to a seatbelt mechanism inside of it as well there. And then of course it has the attachment point right here, which connects to the back of the harness on the D-ring right there. And that's extremely important to attach that properly as well. Okay. No excuses. If you're installing on a composite shingle roof, if you're installing on a tile roof, there's different products for that. You can use the permanent harness anchor here, or the temporary one. If you use a temporary one, you may be saying, oh wow, you know, I'm going to have holes in the roof. Listen, your safety is more important than the holes in the roof. And there are products to go ahead and patch those holes. What we do, we use this all the time. You may or may not, ooh, that's really bright. You may or may not know what this is. This is a piece of galvanized flashing. And if you put holes in the roof here from a temporary anchor, you can simply take a piece of the flashing and cut it to size if you need to. You stick it right under the composite shingle, for example. Works extremely well. And then of course you use your 50-year rated roofer's caulk to caulk it in and seal it in. And it's going to be fantastic. It's going to be rain tight, and you're going to have worked safely on that job site. Very important here to use the proper fall protection system. The next one we'll look at right here is the guardrail system. And so with guardrails here, you can buy guardrail systems. There's several out there that are available, or you can build your own. OSHA allows you to build your own. It does, however, have to support 200 pounds. You can make it out of 2x4s, but it's got to be, you know, built relatively strong. Couple of requirements here. Top rails need to be within 39 and 45 inches. So you can see that in the picture right here. Toe boards are really at the bottom here, and you can imagine what toe boards are for. If you're up there on the roof and something starts sliding off, the toe board's at the very bottom. It just so happens to be the width of a 2x4, 3.5 inches, and so it will stop any tools from sliding off and so forth. The one thing that's not listed on here is the mid-rail. Well, the mid-rail goes right in the middle. So depending on what the height of your top rail is and of course your toe board, mid-rail goes right in the middle there. And then we're good to go with the guardrail system. I like guardrail systems because it allows you freedom on the roof. Although you can see I'm doing my presentation with my personal fall arrest system on right here, my harness on, and this is no problem. I have freedom of movement. You need to put these systems on according to the manufacturer's instructions. That's really important. Sometimes they provide videos. Sometimes there's really nice harnesses that you can buy. They're all padded. Some of them even have D-rings on the front, which makes it actually a little bit easier to work on the roof if you can attach to a different D-ring type configuration and so forth. So keep this stuff in mind for fall protection. Absolutely critical for solar workers on the roof to be using this. And to be honest, it's OSHA. If OSHA were to, and I've worked with OSHA inspectors before in a very proactive way about safety and safety plans and so forth out on job sites, and usually they're pretty understanding. However, if you're expected to wear a fall protection system, and the rule is if you're working 6 feet or more off the ground, you need to have a fall protection system in place. That's super important to understand. And so again, keep these things in mind, and let's be safe out there. I think that's the most important takeaway really from the video. It doesn't take that much longer to set these systems up. It's really not going to slow down your workday. I've worked on job sites for years and years and years installing thousands of systems, and what does it take? 5 minutes to install an anchor? It really doesn't take that long. Your safety is worth it, trust me. Alright, let's continue on. The next one that I'm going to talk about is also part of the Focus or Fatal 4. It's the second largest killer of construction workers at 10%, and of course it is electrocution here. 4 main types of electrical injuries that we see here: electrocution or death due to electric shock. So you're stuck on the wire, you can't let go, and it could cause death. Then there's just electric shock. You get shocked, maybe you let go of the wire, you're able to pull away. Burns right here caused by arc flash or arc blast. And there's an indirect one here, and it's falls, and that's caused by shock as well. So let's run through this here. Excuse me. Severity of shock depends on 3 things: the path through the body, the amount of current flowing through the body, so that's the amperage, and then the duration of the shocking current through the body, so how long you're stuck to it, if you really are stuck to it. Alternating current, looks like a sine wave. We've gone through this in some of the other videos that I've done, I believe, and it returns to 0, okay, in its cycles, in the Hertz cycles, and you're able to pull off with alternating current. With direct current, you're kind of stuck. If you get shocked by it, you're stuck on it, and then it becomes a super dangerous situation. If you are being shocked, hopefully a team member gets a stick or a piece of wood and pulls you off of it. That's really important, because otherwise duration can really cause some harm to the body. Of course, it says here low voltage doesn't mean low hazard. You can get shocked by low voltage. It could be low voltage, it could be high amperage. I think this is a critical slide when we're talking about electrocution. Currents above 10 milliamps, and this kind of puts it in perspective right here. A milliamp is 1,000th of an amp. Currents above 10 milliamps can paralyze or freeze muscles. 75 milliamps can cause a rapid, ineffective heartbeat. Death can occur unless you use a defibrillator. This picture is showing a defibrillator in use. All right, and what that does is it shocks the heart back into proper rhythm. 75 milliamps is not much current. A small power drill uses 30 times as much. That's significant to know. And again, this is a situation with, that may not seem like a lot of amperage, but it's the duration and the inability to let go of the appliance that's creating the electrocution shock. Here's a couple more things. Burns, most common shock-related injury. If an electrocution is happening, let's say you're working in a panel, a screwdriver crosses it, a metal object, you could actually have a percussive explosion happen. That can create burns. That's why it's extremely important to be wearing the proper personal protective equipment when you're working in electrical boxes or on electrical appliances. That may be live, right? What's the biggest rule? Don't work on it live, right? We need to shut it off. That's very critical when we're working on solar systems, is making sure that we are not working live. If you're working on a commercial building, plan on doing the electrical work at hours where it can be shut down. You know, do it after hours. I worked on a restaurant before. We talked to them and we made arrangements to do it early in the morning when they weren't serving customers. Lots of residential projects that I've worked on, just simply telling the customer, hey, listen, from so-and-so time we're going to shut the power off from this time to this time, and it may take a half an hour to do the work that we need to do, or what have you. I think most people, when they realize your safety's at stake, they're pretty reasonable about it. Okay, you guys can read through the rest of that. Falls here, again, that's an indirect situation. This picture really illustrates it well. You're doing some work on a ladder, you don't realize that it's live, you get shocked, and then therefore it's striking to you. You don't expect it, and then of course you're falling off the ladder because of it. And you know, again, falls, #1 cause of death. Here's a couple of things to in regards to mitigating the electrocution type hazards. Proper grounding, so the green wire, and we've talked about that before. Using ground fault circuit interrupters. Ground fault circuit interrupters are required on a job site now. When you're using power tools or power machinery, they're supposed to be plugged into a GFCI, and there are special boxes that you can buy for construction work that provide the GFCI for you. GFCIs save lives. Fuses and circuit breakers really are to save the equipment. It keeps the wires from overheating. It'll shut the appliance off within 1 cycle of the sine wave. With a GFCI, it shuts off the circuit in 1/40th of a second, much faster than a fuse or a circuit breaker would. So GFCIs are for the protection of personnel. Circuit breakers are for the protection of our products and our parts and such. Guarding live parts using the lockout and tagout method, like this particular picture right here. And then of course using extension cords properly, using the right size of extension cord is a big deal. We're not going to cheap out and go over to the hardware store and buy the cheapest extension cord. We're going to take a look at the amperage of the circuit that we're working with and making sure that we have the right gauge wire when we're using extension cords. And then of course training. And I can relate that to what do we do when we work on electrical? We go ahead and we shut the power off. That's absolutely critical. My ring, you may have noticed on here, my ring is actually made out of silicone. And so this ring is what I'll wear when I'm doing any type of electrical work for 2 reasons. #1, it's for electrocution. I don't have anything metal on me with this silicone ring. And the silicone this particular ring will snap at 45 degrees of pounds of pressure, 45 pounds of pressure. So if I'm stuck on something, it won't take my finger off if I'm trying to let go, and that's an important consideration as well. So some of these types of things is part of the PPE. We'll talk about that in just a few minutes. A lot of this is common sense, but safety again is #1 in our solar work. Alright, here's PPE. You can see some types here. I'm not going to get really deep into it, but you know, bright colored reflective vests so you don't get hit by a car. Folks can see that you're working on the job site and that you're a construction worker. Hard hats here, Class E hard hats are for electrical, and they will withstand 20,000 volts. That's very important. for us to wear Class E when we're doing electrical work versus some of the other types, which is Class C or Class G for general. So Class E is our choice in solar. Safety glasses should be ANSI Z87-1 rated, meaning they're impact resistant. Just standard glasses are not going to do it for us. Sunglasses aren't going to do it for us. We need to make sure that we do actually get real safety glasses. If it's loud, we're going to wear our earplugs. If we've got sharp objects, we will wear gloves. I found that mechanics gloves are nice for my fingers. They're nice and tight around the fingers, and sometimes it's hard. It's tedious. You're working with really small parts, so nice tight-fitting gloves work really well. If we're cutting, we're sawing, we have any silica-type dust flying up and around, we should be wearing a respirator. And respirators really need to be medically fitted for us. And if I'm going to wear a respirator, I'm not going to have a beard like I have right here, because that doesn't create the tight seal that you need to wear a respirator properly. Dust masks, things like that are important, but a respirator is really critical when we've got flying dust all over the place. This shows construction boots here. When we're working in solar and we're working on roofs, I don't prefer these, especially high tops, because they're a little bit clunky on the roof. It's hard to walk around, it's hard to do all the kneeling that we do. I prefer like cross-training shoes, but they got to have really thick soles because it gets hot up there, and I've literally had the soles of my shoes melt off before, and so we need to definitely keep that in mind. Knee pads are another great thing that I don't have on here to wear on the roof, and I like to wear soft knee pads. They're perfect for tile roofs, composite shingle roofs. They give you a little bit of support, and you're doing a lot of kneeling anyways when you're on the roof doing solar work, so definitely recommend knee pads. Alright, let's take a look at a few more things here. So I got some other safety topics. We're working with ladders. Alright, this is related to falls, of course. We want to make sure that we don't get falls, so we're setting up the ladder appropriately. Position and extension ladder. We often use extension ladders in solar to go up onto the roof. They're the straight ladders. Oftentimes they're adjustable, they get longer. We're setting them up in a 1:4 ratio. And this particular picture right here, most of these pictures in here that in this presentation are courtesy of just really the OSHA materials have a lot of these pictures in here. The 1:4 ratio is basically for every 4 feet tall, you're going to go 1 foot out with the ladder. And I've often found if you just take your hands, you put them on the rails of the ladder right there, and then the bottom of the ladder is at your shoes, that's about the 1:4 ratio. And you can of course measure it out. It's a tape measure. It takes just a minute to measure it out exactly. The ladder must extend 3 feet above the surface that you're stepping off on. And you may ask, why would it need to do that? Well, I don't know if any of you have ever gotten on a roof and the ladder's just right there at the edge. Getting off's not so bad, even though I kind of end up crawling. Getting back down is really tricky when there's not much there. Having 3 feet above gives you something to grab onto, and then you can step safely onto the first rung. That's really important. And also, you know, when you're harnessed up on the roof, you want to make sure that your partner that's on the roof, who's harnessed already, comes and connects you before you step off the ladder. That's really, really critical and very important. Okay, tying off the ladder, so securing it. We'll strap it to the rafters. Sometimes I've seen folks strap it to the gutter. That's not the strongest part. Make sure that it's tied off good so the ladder doesn't slide around up there. Don't exceed the weight of the ladder. That's really important. And then, of course, when you're walking up the ladder, you don't want to be carrying a solar panel up there. You want to make sure that you have 3 points of contact at all times, and oftentimes we're bringing stuff up with a bucket or a rope or something like that, so we're not carrying a lot of weight up with us. Backpack works too. You can wear a backpack, but your weight and the backpack's weight, that's included in how much weight the ladder will hold. Alright, continuing on here. Here's a few others. Excavations can be super dangerous. Alright, it says here trenches 5 feet deep or more can be in a situation where there's possible cave-in. And cave-in, that's a crushing pressure. That's terrible. That's a terrible way to go. We need means of egress from a excavation, which is a big hole in the ground, or a trench, every 25 feet. There's a couple of protective systems that we use in construction and of course in solar. In solar we're not always doing large excavations and large holes, but oftentimes we're doing trenches. Sometimes they're really shallow and really short, that's fine. Of course we're following the National Electric Code as to how deep it needs to be, depending on if it's next to a road or under the road or under a walkway or where have you. If it's just in the dirt, it doesn't need to be super deep. But of course, follow the NEC for those guidelines. Shoring is a possible way right here, meaning we're securing the edge, the sides of the trench or the excavation so that it will not cave in. Sloping is another possibility, and so when we dig out this, we're going to dig it out so we've got a nice angle right there so that the spoils, which is what you dig out, don't fall back in the trench and create that crushing pressure. So this is a possibility as well. And then shielding, so it's like a trench box that's set into the trench or the excavation, and it's really solid. And you just work in that area, you don't go past and out of that area. This is the safe zone when you're working inside of it. So very important when working with excavations. And we do, again, we do it in solar. We are working with trenches and stuff. This one is power tools. So with power tools, oftentimes on the solar jobs we're using a couple of basic tools. The drill, we're drilling some holes in the roof before we put our lag bolts and our penetrations in. We're using an impact driver to drive those lag bolts in. That's important. And then we'll use a bandsaw to cut rails and pipe and EMT, electrical metallic tubing, things like that. Or sometimes electricians use a sawzall instead of the bandsaw. But these are really common power tools. Oftentimes they're battery operated power tools. And these are some basic safety precautions. You know, disconnect the tool so you don't injure yourself when you're changing bits and things like that, especially when you're putting a drill bit on there to drill holes. You can really mangle your fingers if the drill turns on. So we want to be really careful and follow these particular guidelines that I have on this slide when we're using power tools. And again, a lot of this is common sense, but really take a minute, slow down, think about what you're doing. We want to stay frosty. That means we want to stay alert when we're doing solar work. Alright, that's a rundown of the main safety topics that we're going to experience in the solar industry. This is not a presentation that substitutes OSHA training. Most certainly not. Oftentimes solar employers are requiring their workforce to have at least the OSHA 10-hour training. Some of them require, especially for managers, the 30-hour training. And so it's really, and when I do those trainings, I really try to remind my students, hey, think while you're working. Don't get too comfortable to the point where you take safety for granted. That's really when accidents start to happen. So, super paramount to be safe. I wish you guys the best. I want you to be safe on the website. As always, if you have any questions, feel free to send me an email. It's on my website, solarprofessor.info. There's a lot of good other videos, links, and such on the website as well as materials. And if you need any consulting, you need somebody to do the OSHA 10 specifically for solar, you can certainly contact me, and either I can do it or I can put you in touch with somebody. So anyways, safe solar working out there. We'll see you soon.